Hey guys, welcome back to my Python series. Another day, another Python video. And this time I wanted to talk about classes. This is basically the beginning of object-oriented programming. I'm not going to go too heavily into object-oriented programming in this series, but it is a concept I want to at least introduce you to set the foundation for your learning going forward. So what is a class? Well, let's go ahead and dive right in and I'll show you. All right, I am going to go ahead and create our script right here. I'm going to use the Vim text editor just because it's working better on this machine. But again, if you're using Nano, you could just use whatever text editor you want anytime you see me use Vim. Pretty much the same thing. So I'm going to go ahead and create a class script for us. So I'll just do that right now. Let's call it class1.py. All right, and I set up our basic beginning like I would any other program here. And I'm going to go ahead and write our first class, and then I will explain to you what that is and why you should even care about it. So what is a class? So I'm basically going to give you a high-level overview of what it actually is, and then I'll show you an example here. So a class is kind of like a blueprint. When you are creating multiple things, you might have a mold or a cast or something like that that will allow you to create multiples of that thing and have them be identical. Maybe you might want a few things different here and there, but basically you might want them for the most part to be the same. You might think of it like an assembly line. If you are working at a toy factory, there's going to be a mold or a cast or some kind of assembly line, a blueprint if you will, that the action figure or toy or whatever it is created from. Maybe you need 1,000 of them. And you definitely don't want to create them by hand every single time, and you want them all to be exactly the same. That's basically why you would need a blueprint. And in Python, we're working with objects. Sometimes we want more than one of an object, and we don't want to create it the same way manually every single time. We basically want to create a set of guidelines or a blueprint for that object, so every time we create a new one, it's created the same way. So here, what I'm going to do is show you a class. It's going to be a very contrived example, but I think it'll probably bring the point home. So we start with the class keyword here, and I'm going to use a video game theme just because I like video games. So I'm going to create a class that is called game character, and I'm going to use a colon, and I need to indent this. So it indents 4 spaces. And for my class, I need a constructor. I basically need to write some code for what happens when an object is created from this class. So I'll explain that more in a moment, but to actually write that, I'm going to do def, so basically a function. But it's going to be a special one called init, and it's 2 underscores before and after the init, followed right after that by parentheses, self. This is required. And then I'm going to give it some additional parameters. I'm going to create name and life. And then a colon, I'll press enter again, and we need to indent 4 spaces. In my case, my editor is just taking care of that for me. And what I'm going to do here is actually create some variables. So I'm going to do self.name equals name. Then I'm going to do self.life equals life. So at this point, don't worry too much about what all of this means. I'll explain that in just a moment when it comes to the initialization, these variables I'm using, what self is, and all those things. Don't worry about that just yet. But this is basically how you create a class. So I'm just basically going to go down a few lines here. And we can create some objects from this class, and I think that's actually going to be what will drive this concept home if you don't already know what a class is. So I'm going to create an object called player1, and it's going to be equal to game character. So essentially, player1 is an object that's going to be an instance of the game character class that we wrote right here. However, this is going to require 2 arguments. You see 3 here, but self is required. We're not counting that. There's 2 that we need to provide. We need to provide name and life. So to do that, I'm going to use parentheses here. So for name, I'll just say Roger, random name, I know. And then for life, I'll put 100. So basically, Roger goes here, and then 100 goes here to life. I'm going to create a second object, and I'm going to call it player2. It's also going to be an instance of the game character class. For name, I'll type Betty, and then I'll use 100 for life as well. So what's going on here? So I'm creating two objects, player 1 and player 2. I can create as many of these as I want. I can create 10,000 of these if I wanted to do so. And every single one of them is going to be created the same way. They're all going to be instances of the game character class that we created right here. Now, this initialize definition right here that I set up has three arguments: self, name, and life. But I'm only applying name and life. I didn't actually set up self. Self is already set up. I don't need to worry about that. So this object, player 1, is going to have its own name, which is exclusive to player 1, and player 2 will have its own name, which is exclusive to that object. So now I have these two objects created. What can I do with those? So I'll show you some examples. So I'll just go enter down here a couple lines, and I'm just going to execute a few print statements. So I'll write those, and I will be right back. All right, so I basically created 4 print statements right here. So the first one, I am basically printing player1.name. So that means that the name of player 1, which is this field right here, is going to be printed, and then the same followed by life. And I'm basically doing the same thing for player 2. So I'll go ahead and save the script, and let's run it. Let's see if it works. So basically you see what it's doing already. It's printing exactly what I told it to. We have 2 objects, and it's printing the fields for each one. So back here in my text editor, we can see the value already because these 2 objects can be handled independently of each other. So if I was to go ahead and change this name to Mario, and I'll set this one equal to Bowser, I can basically give them custom fields. And Bowser's a boss, so we got to make him stronger. So I'll give him 150 life, for example. Save the file, and if I run it, we can see immediately that I was able to adjust those 2 objects independently of each other. So even though they each have the same variables, they each have name and life, they have their own name variable, their own life variable, or whatever you want to call it. And a game is a great example of classes, I think, because even if you aren't a gamer in video games, that's just not your thing, you understand the concept. You have a player character that moves around the screen, and you have enemies, and they could all be instances of the same class. For example, your player character has a name, health, maybe jump speed or run speed or something like that. It has its own attributes, but the base is still the same. They could be created from the same blueprint, but adjusted accordingly. And that's basically how a lot of the games are handled. There's a lot of classes and things. You have enemy classes and various different enemies, different player characters and things like that. So this is just a very contrived example here on my screen, but I think it gets the point across as far as what a class actually is. All right, so I wanted to give you guys a more advanced example. I think this one's going to be a lot more fun. So what I've done is I've actually created a couple of classes, and this is going to basically give you a better example as far as how classes benefit us. So it's the similar example to the previous one, but it actually has some additional features built into it. So I'll go over what I've done here. So like before, we have a game character class here on this line, and I'm initiating it the same way. I have self, name, and life, and all this so far is the same. But I do have a new function here, and I called the function attack, and it says self, which doesn't mean it's attacking itself. It means that it's its own implementation of that. And in this case, this function is simply just printing whatever's in self.name, and then it's concatenating the string kicks the enemy at the end. Game enemy is a new class, and it's basically written exactly the same way. I know I've always said don't repeat yourself, and here I am creating 2 classes that are pretty much exactly the same, with the only exception being the last line. They both even have attack. I'll go over how to simplify this more in another example in the same video, but I just wanted to show you this. So if I go ahead and scroll down, you can see that I basically am creating an instance of each class. So I have player 1, player 2, enemy 1, enemy 2. So I'm creating 2 instances of each class. So 2 game characters, 2 enemies here. And then I have the same names that I had in the first example. And then I have enemies here, Bill and Bob. and they have different hit points. Maybe they've been working out at the gym, so their life is higher for some reason. So they'll be more of a challenge. And then as I scroll down here, I'm actually calling the individual functions that were in the original classes. So I have player1.attack. So as you know, we were able to print player1.name, but we can also call a function that exists within a class as well. So player1.attack means that the player1 object created from this class here is going to execute its attack function right here, which is simply just going to print this line. And then here, it's basically going to take enemy1.life. So we created enemy1 right here. And it's going to subtract 50 from its life. And since GameEnemy has its own life, and each instance created from this class will have its own life, we can add or subtract life of each individual enemy separately. So here we are subtracting 50. And then we're simply printing a statement here. The enemy takes 50 damage and then it shows you whatever the current life variable is, but it has to make it a string in order to print it. It just tells you how much life that instance actually has. And then it's doing player2.attack. And then it goes and does pretty much the same thing. This must have been a stronger attack. It's going for 70. And it's going to take that away from enemy 2 life and do the same thing, show how much life is remaining. Now I know the enemies in the script aren't actually doing anything. I just created those as an example. If you want to go ahead and extend this script to make them also counterattack, that might be a fun thing to do on your side. But what I'm going to go ahead and do now is run this script. It says Roger kicks the enemy takes 50 damage and has 100 life remaining. Betty kicks the enemy takes 70 damage and has 80 life remaining. Now I didn't clarify in the output which enemy was being attacked, but you know enemy 1 was being attacked here, enemy 2 is being attacked there. So they're being tracked independently. So just to go over this one more time, just so you understand it, make sure that everything makes sense. We've already gone over the game character class, and again, I just added its own attack function. GameEnemy is a new class I created in this example. It's exactly the same as the first. It even has the function here, attack, but just prints something differently. And then these 4 lines, I'm creating 4 objects. I'm creating 2 player objects and 2 enemy objects. And then I'm just having some fun down here and executing the attack function of player 1, the attack function of player 2, and it just prints some information to the screen about basically taking some imaginary damage. This isn't actually a game, but basically I'm treating it like it was, and you saw the output when we ran it, and it basically showed that right here. So now I'm going to go ahead and extend this even further. So now I have class 3, and all this code will be in the wiki article for this. So don't worry about having to copy everything down. I know that typos get more increasingly possible with the more you type here. So I'm actually adding some additional features here. So each class was given a life check function. You can see that right here, where basically it's just saying if self.life is less than or equal to 0, then self.name, so whatever you add here for name, was defeated is what's going to print. Otherwise, it's going to say is still in the fight. And then I did the same thing here for the game enemy. So basically, it's the same thing as before, where I showed you adding a function to the class, but it's an additional function. This one has an if statement, so it can actually check self.life of that instance of that class independently and print accordingly. Same thing here, I'm creating some character objects, some enemy objects, nothing exciting there. And again, I'm just showing some output here with enemy 1, enemy 2, and the players attacking. And then I actually have some additional things right here. But you can also see that it's doing a life check here for the enemies. So I did incorporate that. So I'll go ahead and minimize this. Let's run it and see if it works. And you can see that it does in fact work. We can see here that an enemy takes 50 damage, has 100 life left, and then another enemy is attacked. But then finally, one of the enemies had taken 100 damage here and has now 0 life remaining, and the life check actually printed Bob was defeated here. Here it printed Bob is still in the fight because when it checked the life, it was above 0, but at this point, since it's 0, it's actually going to print Bob was defeated, which is actually part of the life check here. Now, there was no actual life check being done with the players because there's no counterattack. Again, I'll leave it up to you to add some additional features to this program. Now, I simplified this script a little bit, but not very much, not as much as I should, because I'm still creating two classes that have way too much in common to be separate classes. We'll get into that in the next video, because this video is actually going kind of long. I guess what I'll do is I'll put that in the next video. But in this case, I did add some new features to it, so I'll go ahead and show you what I've done. So far we have the life check function, the attack function, pretty much the same idea here. So I'm going to go ahead and scroll down here. And I have two additional functions that I created, so I'll give you a minute to look at these. But effectively, I have a function that I created. This is not part of either class. This is outside the scope of those classes. I have an attack enemy function and an attack player function. These two functions take two arguments. So attack enemy requires an enemy argument and damage, and the same with attack player. So when you call this function, you're going to need to provide those parameters. And when the function is called, it's going to print the enemy name. So whatever you put here, it's actually going to print the name. And then it's going to concatenate attacks. And then it's going to actually subtract the enemy life by whatever you put in damage. And then it's going to basically print. And of course, we have to convert the things we're printing to strings so that they can actually print. And then it's going to execute the life check. So down here, we actually are creating a player and an enemy object, player 1 and enemy 1. And when we create them, we are going to provide the name. So here's Mario with 100 life. And here's enemy 1, which is an instance of the game enemy class, and named Bowser with life of 150. So when you call the actual function, which we could see here, I'm calling attack enemy. So that's it right here. So just calling the function prints nothing. It just basically calls it or loads it into memory, but doesn't do anything with it. Here, we actually are going to do something with that. So we're going to run the attack enemy function. And as argument 1, we're going to use enemy 1. So that goes here. Enemy 1 was created here. Enemy 1 has its own name and life because enemy 1 is an instance of the class that has those variables. So here, it's going to actually print enemy.name. So whatever you type in here for enemy, in our case, we did enemy 1, which is going to be inserted here. Then it's going to do enemy1.life minus equals damage. Damage was entered here, and we just call that when we call the function. So we just called it at 60, so that inserts 60 here. And anywhere damage is mentioned in this function at this specific part of the program is going to use 60 for that. It's going to print basically everything it needs. And then it's going to do enemy.lifecheck, which we declared here in the enemy class. Scroll up here a bit, we see life check, so it's going to execute that for that specific object. And then down here we actually have a battle. I added some comments here, but you basically can see that we could simply use this attack function for attack enemy or attack player, and then we can accordingly play out the battle as we see fit. So I'll go ahead and minimize this. Let's go ahead and run it, and I called this one class 4. And we can see that the entire battle plays out. We have Mario being defeated, Bowser was defeated. Basically, I know that this isn't going to exactly be even because, I mean, how's somebody going to fight when they have 0 life remaining? But you get the idea. We could basically execute those functions to let the battle play out any way that we want it to. So I know that this was a somewhat contrived example. I know that the theme was system administration in this series. I just thought a video game theme, taking a break from that and showing you something fun like a game just helps understand classes better. I know it worked for me. I had a lot of trouble early in my career understanding this, so thinking about object-oriented programming in terms of video games really helped me out. You don't have to understand game design or even understand games all that well. Even people that aren't a fan of video games knows that you have player objects, enemy objects, and all these different components of the game that operate independently of one another. When you move Mario in a game, for example, it doesn't move the enemies on the screen. it only moves Mario, and then the enemies themselves move according to how they're programmed. And that really helped me understand object-oriented programming. We will be getting back into our theme of system administration, don't worry. Now I know classes is an advanced topic, so take some extra time on this one and practice the examples until you know them well and that you understand the components. Create your own classes and extend my examples further. Now, I will admit, my examples are not that good. There's all kinds of room for consolidating the code. There's a lot of things being repeated. In the next video, we're going to go ahead and consolidate this a little bit more. But even then, there's still going to be further room for refactoring, which is what we call it when we edit a program and clean it up and make it better. And that's what I challenge you to do. See if you can, before you go to the next video, simplify this program even further from how I've done it and see how much you can actually achieve on that, and maybe even extend it to add different attacks to the enemies or any kind of thing that you could think of to get the idea of classes. And then in the next video, we're going to go over inheritance, which is another object-oriented programming term, and I'll see you there as soon as I have that uploaded. Thank you so much for watching my video. If you want to help me out, go ahead and check out the links in the description below, and there you'll find a link to purchase my latest book, Mastering Ubuntu Server, 2nd edition. You'll also find a link to my Patreon page, as well as my Amazon store, which includes a listing of Linux-compatible hardware that I've tested personally. Thanks again for watching, and I'll see you in the next video.